This presentation is intended to provide an overview of the Bruker molecular imaging software package. The primary focus of this presentation is image preparation and data analysis. We will overview some basic aspects of image acquisition, however, this is not the primary focus of this presentation. The software is an integrated acquisition and analysis software package. For the software installed at the control unit, a Capture in Vivo button has been activated. From this menu, we can drive acquisitions. In the overhead toolbar, there are several buttons that activate menus for data analysis and image preparation. Again, for the software installed at the control unit, a Capture in Vivo button has been activated. With the In Vivo Extreme Capture menu, we have a standard view and we have the option to expand to the advanced view. Our view includes a menu for selecting our foreground acquisition and our background acquisition, so it will provide a means for acquiring in sequence a foreground along with a background acquisition. If I change my modality here, the setting pull-down menu is populated with the available settings for that particular modality. We'll show a sequence for manipulating the capture menu. So you can see in this example, if I select luminescence, the settings available are luminescence, and the background settings here are X-ray reflectance, exposure time, and lens settings. And then if I look at the advanced menu, I can see more options. The Capture in Vivo Multispectral FX Pro menu has a single modality capture, so there's execute each individual modality individually, and we'll show the process here for programming a new setting. The process is similar for the In Vivo Extreme. So we can start out at the setting menu, either creating a new name or simply going to current session while we make changes. Select the illumination source multi-wavelength for a fluorescent acquisition. Set the exposure to 1. A typical exposure time for fluorescence is anywhere from about 2 seconds up to 10 seconds. We might reduce our binning. This will reduce our sensitivity but increase our resolution. Increase the f-stop, which closes our aperture down partly, and then set our excitation emission filters. Finally, in this case, we'll give the capture setting a name last. For recall, we'll call it green floor. OK, and then I would select Save to make a final update. Both the Multispectral FX Pro and Extreme systems offer a protocols option. Here we can program multi-step, multispectral, and Mars acquisitions. So you can access the protocols menu for programming and executing protocols either directly from the toolbar, or there is a button within the capture menus to access this menu. We'll show an example for creating a protocol, a simple 3-step multi-step protocol. You can see here in the capture menu that once you've created a protocol, you do have the option to select it from the pull-down menu and execute it directly. We can access again the protocol menu for programming and executing from the toolbar, or if we select advanced here, we can indirectly access the same protocols menu. So in this case, just showing there are no protocols programmed at this point. We'll go to the protocols menu. We'll enter a protocol name. It will be a fluorescent luminescent X-ray protocol, so that when you execute the protocol, it will execute in sequence those 3 steps. Step 1, we'll select green floor for a simple multi-step. We'll ask the system to open the image in MI. For our multispectral or Mars acquisitions, we do not want it to open up all of those images in MI. And finally, Step 3, we'll select an X-ray setting. And then update. Just to show as well, we could change the path for the protocol images to be saved. So this is one way to organize our file folders. Once you've completed your acquisition, typically you'll access the image display tool. The image display tool, as the name implies, is to adjust the display for your image. We can contrast our image using the min and max tools. We also have some quick unit conversion buttons here to convert to the most frequently used in vivo units, and it does also have some tools to facilitate data analysis. We'll next show a few sequences for image display manipulations. And the first example, we'll look at contrast and overlay. In this example, we'll use a mouse that has fluorescence in the kidneys as well as X-ray contrast in the kidneys. In order to create an overlay, typically we will want to adjust the display. So to do that, select the bar over the image that you want to adjust, select display. We'll invert the image so that the background is black. Next, we'll select the background image, and in the image display, select overlay and make sure you select the transparency checkbox. Return to the foreground image, the fluorescent image, and then contrast the image. The elements that are dark will be shown as transparent onto the background image. And then finally, we can export the overlay image, selecting the overlaid image, and then File, and Export Image, and then JPEG, and then we can save this to a path. You can see here the JPEG that we've created. In this example, we will show the process for converting in vivo luminescence units to photons per second per unit area, which is the most common unit used for in vivo luminescence. So you can see the units are currently in counts, and we select the image in photons per second per unit area, and the units are converted here. In some cases, we would like to make adjustments to multiple images at the same time. For example, if we're looking at a longitudinal data set, we might want to see relative visual comparisons. So we would want to set the min and the max for all the images to the same values. So in this example, we're looking at biodistribution for a fluorophore over time. I can go to Window Tile, so 3 different time points. If I maximize my image display and then I select the link checkbox, I can link different subsets of images from the pull-down menu. In this case, we're simply going to select all of the images, and I can go to display lookup table. In this case, I'll select rainbow, and now you can see with the link checkbox, if I make changes to the min and the max, it adjusts those values the same across all images. If I link zoom pan only my zoom pan will be linked. I also can select synchronize ROIs, and this facilitates higher throughput analysis. So with synchronize ROIs selected, as I draw a region of interest on one image, it applies it to all images. Now if I needed to make an adjustment to one of the images, I can unsynchronize the ROIs, select the arrow in the manual ROI, and make a adjustment to the position. Could change the background. In this case, we'll select the minimum. The background is derived from the perimeter of the ROI, and then select the Analysis tab to look at data. The in vivo multispectral FX Pro and Extreme systems produce images that are in the .bip file format, which is a proprietary file format. It has a meta file associated with it, so the analysis data that you create can be carried over, and the info history meta file associated with your image can also be carried over, so you can transfer that with your image. In some cases you would want to export the image to a different file format. We already showed the method for exporting an overlay to the JPEG format. You can use that same method to export individual non-overlaid images to other file formats. There is also a method for creating a batch export. I'll show that process here. In this case, we'd select File, export multiple, and then we'll select our files to be exported. And we might change the file format to JPEG, for example. We'll remove the metadata, and then we can select a path for the export. In this case, we'll use the same path that the BIP image file format images are located, and then we simply export. Once we have our data sets, we might next access the navigation menu. The navigation menu includes many of our data analysis tools. So within the navigation menu we have image. This includes some image math functions and some basic rotation and cropping functions. We'll look at our ROI, our region of interest tools, our manual ROI, and our auto ROI tools. We won't look at the grid ROI or lanes tools. These tools are primarily in vitro tools. And then annotation and database are also included in the navigation panel menu. So we'll look at an example of using the image tool with a mouse image with fluorescence and X-ray for the cranium region. So we can access some submenus. Image display, we can also access our info history. So this includes acquisition details as well as manipulations that have been performed on the image. We could add comments to the info history. You can see here, if we return to the info history, the comments now at the bottom as the most recent addition. We can perform basic clockwise and counterclockwise rotations. We could adjust the signal orientation for image. Right now, bright is positive and dark is low intensity, but you can see here we can, with our cursor, view per pixel intensities. With image math, we could change to some additional units or different addition and subtractions for multiple images. We can crop our image using a we can rotate our image using a visual rotation tool, or crop our image simply by selecting our area and then cropping. The two primary region of interest tools used for in vivo analysis are the manual ROIs and the auto ROIs. As the name implies, manual is for creating ROIs in a manual method, and auto sets parameters to automatically identify regions of interest, target regions. So we'll select our manual ROI. Typically we'll select ellipse, draw from the corner, left to press, and drag your ellipse over your target region. Once you've created your first ROI, left to press, hold to depress, and drag to copy and paste a new ROI. To make adjustments to the perimeter, select the arrow, and then you can adjust the boundaries for the ROI. We'll set the background to minimum. So again, we'll get the the background will be derived from that perimeter region where the ROI is drawn. We can change the default metrics in our analysis table so we can have different values here. Most users are interested in the net value. We can look at our values relative, so if I select a ROI reference, I can look at them, for example, as a percent difference. Delete this ROI set. We do have a magic wand option. If I click at the edge of my perimeter or left to press and drag along the edge, depending on how I use the magic wand, it will use a different algorithm for identifying regions of interest. The auto ROI, there are different algorithms for searching for your regions of interest using auto ROIs. We'll set our search area, new ROI. In this case we'll use density slice, which is quite common for in vivo data. And then we simply use the visual display, setting the density slice and find to create an ROI. If I want to make adjustments, I make adjustments, and then I can select replace, and we'll create a new ROI set based on the new density selection. Using the database tool, we can manage our image data sets. One thing to point out first is if you decide you don't want to use the image database, you can go to preferences and select to not use the image database. If you have the database turned on, you will be prompted when you save your images about how you want those images to be saved in the database. This is viewing some of our images in the database. We can set different investigators, assign different job functions. We can search our database. So we've already shown a method for creating an overlay for a dual modality image. In some cases we may want to overlay more than two modalities. We could utilize the multiplex tool to overlay up to 4 modalities. And for an example, we will look at a trimodal image with X-ray and then a mouse with two different fluorophores, one type of fluorophore in opposite limbs. The easiest way to utilize the multiplex tool is to have your images opened and saved in MI, and then select multiplex, analyze. You may need to select yes or open as the images are processed. Here we can adjust the display. We'll switch the color display for the floors and the limbs. We can adjust the brightness, and we can export various elements of the multiplex or deselect elements. Change the export format to JPEG. So right now we have only the overlay, the full overlay, and we can change the default path for the export image. Select it to the desktop and then export. And then if we look at our desktop, we'll have a JPEG for this overlay. For questions relating to the Bruker molecular imaging software, please contact molecular support at bruker.com.